How big is your room? Or how much paint do you actually need for that wall? How much stuff can you fit in that box? These are questions we kind of answer every single day, and we do it using one of our oldest and most powerful tools, measurement. It's fundamentally how we make sense of the physical world around us. So let's dive in and see how it all works. All right, so here's the plan. First up, we're going to explore why measurement matters so much in the first place. Then we'll get the basic language down before we tackle the distance around a shape, that's perimeter, and then the space it covers, which is area. And to finish things off, we'll take all that and build it up into the third dimension. Okay, so let's kick things off with a big question. And I mean a literally big question. How on earth do you go about measuring something as massive and, let's face it, weirdly shaped as an entire country? I mean, think about it. A country isn't some nice, neat square you can just measure with a ruler, right? But figuring out its area is absolutely crucial for things like calculating population density or tracking how land is being used. So, how do surveyors pull it off? Well, here's the secret. They break that huge, complicated shape down into thousands of smaller, much simpler shapes, things like triangles and rectangles. Basically, shapes we actually know how to measure. Okay, but to measure anything, doesn't matter if it's a country or a crayon, we need to be speaking the same language. We need units. So let's take a quick look at the basic vocabulary we use to describe the world's dimensions. So when we talk about measuring, we're actually talking about a few different ideas. First, you've got length, right? The distance from point A to point B. Then there's mass, basically how much stuff an object is made of. We've also got capacity, which is just how much a container can hold. And then there's area, the amount of flat space something covers, and we are definitely going to dive deep into that one soon. And each of these has its own set of units, its own language. And hey, knowing the units is one thing, but knowing how to switch between them, that's just as important. Now, the metric system is awesome because it's so simple. It's all based on powers of 10. Like, there are exactly 1,000 meters in a kilometer. Super straightforward. And we also have some handy approximations for converting to imperial units, like remembering that a meter is roughly 3 feet. And the rule for converting? It's actually super simple. When you're going from a bigger unit to a smaller one, say from kilometers to meters, you just multiply. And that makes sense, right? Because you're going to have a lot more of the smaller unit. And to go the other way, from small to big, you guessed it, you just divide. That's really all there is to it. All right, so we've got our units sorted. Now it's time to actually start measuring some shapes. And we're going to begin with the most straightforward concept there is, perimeter. Just think of it like you're taking a walk right along the very edge of a shape. Now, before we go any further, let's make this crystal clear, because it's important. Perimeter is the line around something. It's a one-dimensional length. Area, on the other hand, is the surface inside those lines, a two-dimensional space. Think of it this way. The perimeter is the walk, the area is the lawn you're walking around. So calculating perimeter is pretty much as simple as it sounds. You literally just add up the lengths of all the sides. So for this rectangle here, we've got 3 centimeters plus 2 plus another 3 plus another 2, which gives us a grand total of 10 centimeters for the perimeter. See, we've just walked all the way around it. Okay, we've walked the line. Now it's time to move inside and figure out how to measure all that space enclosed by the perimeter. It's time to talk about area. So how do we find the area of our rectangle? Well, the formula is nice and simple, just length times width. In this case, that's 3 centimeters times 2 centimeters, which gives us 6. But 6 times what? This is key. It's 6 square centimeters. See, we're not measuring a line anymore. We're measuring how many little 1x1 squares can fit inside. And that's why the unit gets that little 2 up top. Okay, rectangles are straightforward. But what about a triangle? Now, this is where things get really clever. If you look closely, any triangle, seriously, any triangle, is just half of a rectangle that fits perfectly around it. It takes up exactly half the space. And that one simple idea, that's the whole key to finding its area. So if the triangle is just half of the rectangle, then all we have to do is figure out the area of that imaginary bigger rectangle, which we know is base times height, and then just chop it in half, divide by 2. And boom, there it is, the formula for the area of any triangle. And you know what? This whole rearranging trick works for other shapes too. Check out this parallelogram. It looks kind of tricky at first, right? But watch this. If you just slice off that little triangle on the one side and slide it over to the other, just like that, presto, it turns into a perfect rectangle. And because of that clever little trick, the formula for its area is almost identical to a rectangle's. It's just the base multiplied by the height. Now, the key thing to remember here, and this is super important, is that we're talking about the perpendicular height, the straight up and down height, not the slanted side. All right, our last 2D shape for today is the trapezium. The special thing about this one is that it has two parallel sides, but they're different lengths. We'll call them A and B. So to find the area, we do something kind of cool. We find the average length of those two sides. You just add A and B together, divide by 2, and then multiply that average by the height. Okay, so we've pretty much mastered the flat 2D world. Now it's time to level up. Let's take everything we've just learned and build it up into the three-dimensional world that we all actually live in. So how does our 2D know-how connect to 3D? Well, take a look at a cuboid, which, by the way, is just a fancy word for a regular old box. If you could somehow unfold it and lay it flat, what would you see? You'd see it's really just 6 rectangles, all folded together. This unfolded version is called a net, and it's the absolute key to understanding surface area. So it's pretty simple then. If a cuboid is just made up of 6 rectangular faces, its surface area is nothing more than the total area of all those faces added together. And here's the good news. You already know how to find the area of a rectangle. So you just do that 6 times, add up your answers, and you're done. But wait, that's just the wrapping paper, right? What about the actual space inside the box? Well, that's called volume. We're no longer thinking about flat squares. Now we're measuring how many tiny cubes can fit inside an object. And that's exactly why our units get that little 3 for cubic centimeters or cubic meters. And honestly, the formula for the volume of a cuboid is just so intuitive you'll love it. It's simply length times width times height. That's it. You just multiply its 3 dimensions together to find the total space it takes up. So for this example here, that's 6 times 4 times 2, which gives us 48 cubic centimeters. So let's just take a quick step back and see how far we've come. We started with a simple line, the perimeter. Then we filled in the space inside that line to find the area. Along the way, we learned the language of units to describe it all. And finally, we took those flat shapes and built them up into 3D objects, so we could measure not just their surface, but also the volume they contain. So I want to leave you with a final thought. Measurement isn't just some abstract math concept. It's really a new way of seeing the world. That screen you're looking at right now, the room you're sitting in, the building you're in, they're all just collections of simple shapes. And the cool thing is, you now have the tools to describe and measure your world with total confidence.